Hello community! Today, no, not the LLama, we go for the Mistral 7B Instruct model, yes! And we are running here on Perplexity Labs, and we have here an in-context learning. So what we do, we go here. Does this work? Yeah? Okay. So here we give here a simple ICL. We tell him, hey, you are a specialized LLM trained to assist with inquiries into theoretical physics and computer science. This is an example. User, let's make it even clearer. What is the significance of dark matter? The model comes back, this is dark matter with this context set. Now you ask the user, how may I assist you? So the system comes back, so Mistral 7B comes back, it gets here the ICL, a 7B model, nice. Please provide me with your specific inquiry or research topic, and I will provide you a detailed, scientific, accurate answer that references relevant literature. Great, so what we do, we ask here, explain what is an agent in AI and give me a simple example of one. And here we are. As you can see, close to 100 tokens per second, great. In AI, an agent is a software entity that perceives its environment and takes action to achieve its goal, can be sort of a self-contained system that interacts with its environment through sensors and actuators. A simple example of an agent in AI is a robot that navigates through a maze, perceives its environment through sensors such as cameras and sensors, touch sensors, and it takes actions to move through the maze by using actuators such as motors or wheels. In more complex AI systems, agent can be used in a variety of applications such as autonomous vehicles, drones, robotic systems. The key characteristic of an agent is its ability to perceive and act in its environment to achieve its goal. Great. And now say design a use case where three agents interact with each other, and explain how. So Mistral 7B comes back. Agents interact with each other could be a multi-agent system for traffic management in a smart city. In this system, three agents are designed to work together to optimize the traffic flow and reduce the congestion in a city. The first agent is a traffic light controller that manages the traffic signals intersections. The second agent is a traffic management system that monitors the traffic flow and provides some real-time information to drivers and to other traffic controllers. The third agent is a traffic prediction system, maybe an AI system that predicts here patterns that it was recognized in the past and uses machine learning algorithms to predict traffic patterns and congestion. The traffic light controller agent number 1, is responsible for controlling the traffic signals at the intersection. It receives information from the traffic management system agent about the traffic flow and congestion, and it adjusts the traffic signals according to optimize the traffic flow. Now, the traffic management system, number 2, is responsible for collecting and analyzing real-time data about the traffic flow and congestions. It receives data from its sensors and cameras installed throughout the city and provides this information to the traffic light controller agent and the third agent, the traffic prediction system agent. Now you know, the third agent analyzes historic traffic data, learns from this historic traffic data, and discovers the pattern, and is able, therefore, to predict future traffic patterns that are based on the historic data. It provides this information to the traffic management system agent, which can then use it to optimize traffic flow and reduce congestion. So, I tell you something, for a 7 billion trainable parameter model, this use case of 3 interacting AI agents is not bad, honestly. You can go there and maybe try LLama 270B model on the same stuff, and you might be in for a surprise. So I say, hey, give me some pros and cons of a coordinating agent that supervises here the information flow and integrate each of the 3 AI agents at the correct time whenever the task requires some data input. So whenever we need some information to analyze here a situation and have a successful task execution should we have a coordinating AI agent. And here we have it from Mistral 7B, and I really like this small little model. It outperforms Llama 2, the 7B, and the 13B model significantly. Look at this. Pro. Improved efficiency for a coordinating AI agent. Optimize information flow. Working together efficiently. Okay, this is a standard sentence. Enhance decision making. Integrate information from multiple sources and provide a more comprehensive view of the system, of the overall system. A system that integrates the subsystem of all three AI agents, allowing for better decision making. Flexibility. The coordinating AI agent can adapt to changes in the system and adjust the information flow between the different AI agents as needed. This I find very, very useful, because if you have not the starting boundary condition of your physical system, but the system changes, it adapts with the time series, you need here an overarching intelligence to adjust the information flow, since the situation itself changed from the very beginning. So if you have a dynamic system, you need, I found out that in my cases, a coordinating AI agent that supervises three other AI agent, task-specific AI agent, is really helpful. Scalability. Coordinating AI agent can handle large numbers of AI agents and manage the information flow between them, making it scalable for more complex systems. Cons. Cons is more exactly, can be too complex to design and implement, requiring a deep understanding of the different AI agents and their interactions. And this is the main reason why I always have GPT-4 as my central coordinating agent. Because you need really the biggest, most powerful AI system you can get your hands on. You have some compute overhead in your system, okay? Single point of failure. Can be a single point of failure, yes, but on the other hand, if one of the three sub-agents fail, the coordinating AI agent can maybe create a new agent or eliminate an agent that is not performing as expected. Or the different AI agent may become dependent on the coordinating AI agent and maybe makes the system less robust and resilient. Interesting, but we can take care about this. So, next question. So we say, hey, would it be possible to code a central intelligence with the ability to create maybe a fourth agent when it is needed for a specific upcoming task? And here, Mistral 7B, let's see if it's still logic and reasonable. Yes, it is possible to code a central intelligence with the ability to create an agent when needed for some specific upcoming task. This is known as a dynamic agent creation, and it involves central intelligence creating agents on the fly as needed. Agent template. A central intelligence can have a library of agent templates. You define, before the system starts, that you have 10 expert systems, and you want that each expert system performs a particular set of tasks. So if you fly to Jupiter, you know what the atmosphere is, you know the temperature, you know what the hard radiation will be. So you can think of intelligence pattern that we need to analyze some obstacles over there. Agent factories. Factory based on a set of parameters. Agent composition. Compose for smaller, more specialized agents to perform specific tasks. Modularity. Now this is the modularity of your whole system, and we'll talk about this in another video. Robotics. Central intelligence can create agents on the fly to perform tasks like as grasping objects or navigate through a maze. If you suddenly enter a maze, the central intelligence agent says, hey, I want to have now an agent that is specialized and has been trained on how to find the best way through a maze. This AI system, this AI agent has been trained on 100,000 mazes. Autonomous vehicle. lane keeping, obstacle avoidance, smart home. You interact with other agents in your home, and you have from controlling lights, adjusting the thermostat. This all can be done by agent that receive here the environmental factor, know your behavioral pattern when you come home, when your family is home, what you do, and be here an AI system instead of just here a template. So overall, dynamic agent creation can be a powerful tool for building intelligent system that can adapt to changing requirements and perform specific tasks on the fly. Now I tell you, for a 7 billion, the smallest size model, I am impressed with Mistral 7B Instruct. Why not try it out yourself? You go to labs, perplexity.ai, you put in your beloved system, and you can give it a try yourself. So, and now for the ultimate test. Can you design a prompt for an LLM? We ask here our Mistral system to create 3 agents and 1 central intelligence agent. How would you create such a prompt? Show me the way forward and provide me with 3 examples. So, Mistral 7B comes back and designs a prompt for me. Nice, really nice. Try this with any other 7B model and look at the quality. So here we have our prompt for an LLM. Design a system, traffic management, 3 agent, yeah. Define agent 1, define agent 2, define agent 3. What is the task here of, for example, a traffic management system? Collect, analyze real-time data, information, use machine learning algorithm, predict traffic, provide this, yeah, should be optimal and reduce congestion in the city. Okay. Now we have here 3 examples of how the prompt could be created. Okay, create a system for, design a system in a smart city. Okay. So as you can see, you got here 3 options of a prompt for an interactive multi-agent AI system. Let's compare the FALCON 180B to Mistral 7B. So let's do the ultimate test. Mistral 7B Instruct. We are running Perplexity Lab, and let's do here something nice. So we say, hey, GPT-4, now have a mind, you have a central intelligence, you create specific agents. Yes, yes, yes. Let's see if this is working. Hey, it says, hello, I'm GPT-4, your central intelligence agent. To begin, could you please provide me with a specific task that you would like me to help you with? And I say, of course. And you know what? You know what we're gonna do? We do something beautiful. So this is the identical task that I also looked at FALCON 180B. Let's see if the system is able to do this. Could you please provide me with more information about your current YouTube video production process and what you're looking for to improve? I read newly published preprints and scientific publication about new technology or new coding sequences for AI. And then I try to understand in my little brain this new scientific idea. And then I try to generate an explanatory video where I show you the idea, the theory, the new code sequences. And I publish the video for my YouTube viewers. And Mistral 7B comes back and says, understood, based on your task, I create 3 expert agents to assist you in generating more creative and engaging YouTube videos. First agent, video editing and production. Second, AI and technology research. Third, video scripting and storytelling. And in my original prompt, I have here each agent will introduce itself to the user with its name, its specific competences, and its tools it can apply to find a solution. And then the user will choose 1 agent and even can add some competences or solution idea. And this agent will be here the interactive agent. And here we have it. Expert agent 1 says, hello, I am and have experience in. My tools include, Agent 2 introduces itself. Hey, I'm in AI technology research. Yes, yes, yes. My tools include databases, research paper, data analysis software. Agent 3, hey, I'm video scripting and storytelling. My tools include framework, scripting software, character development techniques. And you see, this is great. So now please let me know which expert agent you would like to work with first. So here's now an interesting way. For example, we could create a video series that follows the development of new technology or coding sequences for AI, or we could create a video that compares and contrasts different AI models and their capabilities. Expert Agent 2 says, hey, that's a great idea. I can add to that by suggesting that we also research and include information about the latest development. Keep your content up to date, okay? And agent number 3 comes and, I agree. I would also incorporate elements of storytelling into our videos and make it more engaging and memorable. We could create a narrative that follows the journey as they work to develop new technologies. So I say, okay, now continue with this interaction process. Now it gets interesting. Yes, a 7B model. My goodness. Visual elements in the video, making it more engaging and memorable. Great idea. The latest development in, yes. Elements of humor, okay. Continue with the interaction process. Let's create more ideas. Let's do the brainstorming. Yeah, now we are in a repetitive loop. But I think for a 7B model, my goodness, not bad at all. So there we have it, a reasoning test for Mistral 7B. Now let's go to the outlook. What can we build upon these insights? Now, next step would be a multi-agent interaction coding, where we have some similarities with some mixture of expert agents or expert systems, you know. But as I already told you, I'm still missing here the chain of validation. Now we can use another approach. We can use this as an agent, and we will apply this agent on our Mistral 7B. I could show you how we integrate here the validation chains into this system, or maybe we do something else. We do here that Microsoft's AutoGen is now simple to understand because we have all the ingredients. We understand already the basic terms, we understand already the complete interaction mechanisms. And since AutoGen is just a multi-agent conversation and not an interaction with robotics element, AutoGen might be the topic here of the next video. It is very simple, it is a nice walkthrough, and in the end you will absolutely understand Microsoft's AutoGen. So, this is the outlook for maybe the next videos. Let's see what comes up. Anyway, I hope it was interesting. I hope you have some new ideas. Maybe you give here the Perplexity Labs a try to explore your specific model, to compare models here. And it would be great to see you in my next videos. And if you want to prepare yourself for the next video, here are maybe some informative videos for you where I summarize what is an agent. I give you an example how we can use one agent, how we can use multiple agents, how GPT-4 is able to create synthetic agents, but more about this in the upcoming videos.